This video is for the systems of equations foldable. To put this one together on the center gray line, you're going to fold to the dotted line. And then where you see these large dashed lines, you're going to cut. So once again, this video is for the systems of equation foldable. So we're going to start with one solution. So if we have a system of equations, we have two equations, and they're going to have a solution. That solution is a value that will work for both equations. So if you plug in the x value, you're going to get the same y every time. It's also where they cross on a graph. So the equation only has one solution in a situation like this. The lines will have different slopes. The lines may have the same y-intercept. And the graphs of the line will cross at one point. So we can graph these by hand, and you can also graph these using a graphing calculator. And the TI-84 and Inspire both will do systems of equations for you. So let me turn my stat plots off, and we'll go into y equals. So I can type my equations in here, 4x plus 3 and negative x minus 2. So if I graph these, when you're doing this, especially in the TI-84, you need to make sure that you can see where the lines cross. And once that happens, second trace 5, and then you can hit enter 3 times, and it gives you an ordered pair, -1, -1. That is the solution to that system. So the other way that I can do this is I can set the two equations equal to each other. 4x plus 3 equals negative x minus 2, and then I can solve. So if I add x to both sides and then subtract 3 from both sides equals -5, and then I'm going to divide by 5. So in the end I would get x equals -1. And then what I can do is I can take that value and plug it back into one of my equations. And then plus 3 and solve it. So 4 times -1 is -4 plus 3 gives me -1, and that would be my y value. So that is my solution, -1, -1. And then you can also graph these. So 4x plus 3, 1, 2, 3, 4 over 1 would look something oh, I went up too high. It should be here. Sorry, that's where my 2 points should be. I apologize. And so there's my first line. And then my second line, negative x minus 2. Let's see if I can get another value in there. And so you can visually look at the graph and see where the two lines cross to see where your solution to the system is. So if you have infinite solutions, every solution will work for the system. The lines will have the same slope. The lines will have the same y-intercept. And the graphs of the line will be exactly the same. And so for this one, I'm just going to graph my two lines here. The best way to do it on this graph paper is 1, 2, 3, 4 is to label it by fourths. 1, 2, 3, 4, 2, 3, 4, and that way you've got fourths to work with. So my y-intercept, 2, 3, I didn't go up high enough. So there's my y-intercept, and down 1, 1, 2, 3, 4. You can calculate your slope. 1, 2, 3, 4. So there would be my first line. And then my second line, 5x minus 15 over negative 20. So this one is a hard one to graph by hand. One thing that you can do, again, I highly recommend using a graphing calculator anytime that you're solving systems of equations. But one nice thing, if you do have to graph them physically, you can use the graphing calculator to pull values. So 5x minus 15 over negative 20. And so what I mean by pull values, you can do second table and you can pull values. So 0 and then 3/4. And you'll see that all the points line up here. Negative 1, let's go up to negative 1. Negative 1 is at positive 1. And then if we go down to positive 1, it's at 1/2. So when you graph, and the two lines are exactly the same, they line up, all their points are identical, like we have in this situation, you have infinite solutions. So I do recommend, if you're doing this in a graphing calculator, so let me put this other equation in really quick. So negative 1 over 4 x plus 3/4. So if I graph these, I always encourage my students to watch the graph. So there goes my blue line, and then you can see the red line trace right over it. So if you're using a graphing calculator, pay attention to what is happening when you graph the equations. So finally, we have no solutions. So no solution will work for the system. The lines have the same slope, but they will have different y-intercepts. And so the graphs of the lines will be parallel. And so again, if you graph these by hand, you will see that. And again, I warn my students when they are doing these with a graphing calculator, and I can show you on this one, negative 2x plus 2, and then negative 2, open parentheses, x plus 2. And anytime that you have equations like this, again, if you're having to graph them by hand, pull them from the calculator, from the table, or create your own table and plug in x and y, or x values, and then get your y value out so you get accurate data points. So if I graph this one, there's my blue line, and then you can see that my red line is parallel. You can zoom out. Again, I always encourage my kids to zoom out. And if you do second trace 5 on this one, you will get an arrow. Sorry, I went too quick. Second trace 5. You get an error, no sign change, meaning that the two lines never cross. And so for this system, there would be no solution. Again, you can also graph by hand. You can also set the equations equal to each other to find your solution.